Hello, classmates. Welcome to the Food Quality Management class. Today, we will learn about one of the 7 new quality management tools. The core tool specifically designed to sort out the causal relationships of complex problems is the association diagram. In food quality management, we often encounter tricky issues, such as microbial contamination, exceeding standards, shortened shelf life, and the presence of foreign objects. These problems are often caused by multiple factors. Rather, it is a complex interplay of multiple factors, where each factor is both a cause and an effect of the others. The traditional fishbone diagram can list the causes, but it is difficult to express multiple feedback relationships. The association graph is precisely designed to address this complex causal chain, where you have me and I have you. Master it, just like having a cause and effect map. Help us quickly identify key nodes in the fog. Make precise efforts. The correlation diagram is used to represent complex and intertwined problems and their influencing factors. Use arrow connections for diagrammatic analysis. Thus, we can quickly identify the main factors and core projects. It was developed by Professor Jimuki Senju of Keio University in Japan in the 1960s. Nowadays, it has become an essential tool for enterprise quality management and on-site improvement. Its core idea is no problem is isolated. Factors will influence and reinforce each other. It even forms a vicious cycle. Through the direction of the arrow, we can clearly distinguish which is the cause, which is the effect, and which is both a cause and an effect. This graphical thinking greatly enhances the efficiency of team analysis and problem solving. Well then, what are the application scenarios of association graphs? First, complex causal entanglement analysis, clearly sorting out the issues of multiple factors interacting with each other. The batch-specific off-flavor of food may be related to raw materials, processes, equipment, environment, etc. Second, grasp of on-site issues, assist in quickly locating the root cause in production and service on site. For example, the production line suddenly stops, and the packaging is poorly sealed. Third, market research and customer complaint analysis accurately identify the core reasons for customer dissatisfaction. If consumers complain about changes in taste, the underlying reason may be the accumulation of multiple links, such as formula, storage, and transportation. Fourth, the implementation of policy management, assisting in problem identification in the process of achieving and executing corporate goals. You could say, as long as it involves a multi-factor, complex causal work scenario, the association graph can play an important role. It is especially suitable for the food industry, a field characterized by a long chain, multiple links, and dense risk points. Next, let's look at the core characteristics of the correlation diagram. This is also the key that distinguishes it from other analysis tools. First, it is suitable for organizing problems with very complex reasons. Organize the messy factors into a clear order. Even non-professionals can understand it at a glance. Second, through visual presentation. Team members can stand in front of the same picture to discuss. It is easy to reach a consensus. Third, from the planning stage, we should approach the problem with a broad perspective. Avoid being confined to local details. Fourth, the form is free. There is no fixed template. Arrows can connect in any direction. Suitable for quick organization after brainstorming. Fifth, it can break preconceived notions. As you continue to paint, you will realize that what you initially thought was the primary cause is actually just an intermediate factor. The true root lies elsewhere. What types of association diagrams are there? From the perspective of purpose. The multi-purpose type is suitable for analysis with more than two objectives. For example, analyze the common underlying causes of both rising costs and decreasing pass rates simultaneously. The single-purpose type is targeted at a single problem. For example, analysis of the causes of can swelling in a certain batch of cans. From a structural perspective, the centralization type focuses on the core issue. All factors radiate outward. It is suitable for situations where the problem is clear and the causes are scattered. The unidirectional aggregation factors extend in a single direction, like a chain, suitable for scenarios where reasons and results are one-to-one corresponding and progressively advancing. The application-oriented approach can be used in conjunction with other tools, such as system diagrams and matrix diagrams. For example, first use a correlation diagram to identify the key factors. Then use a matrix diagram to evaluate the feasibility of the countermeasures. Thus, the depth of analysis and the quality of decision-making can be improved. In practical work, everyone. It can be based on the nature of the problem and the team's habits. Choose the most suitable type flexibly. You can even combine multiple types for use. Achieve the effect of 1 + 1 and GT2. How to make the association diagram? There are 9 steps in total. It is simple and easy to operate. Step 1. Decide on the topic. Write the analysis theme in concise and clear language. For example, the pH value of a certain beverage production line fluctuates greatly. The second step, team composition. Gather personnel from relevant departments, such as production, quality control, equipment, procurement, etc. Ensure multi-perspective input. Step 3. Data collection using brainstorming method. Encourage all members to speak freely. Search for possible reasons. No restrictions. No criticism. Step 4. Make cards. Write each factor on a card or sticky note in simple and clear language. Write one factor on one card. Easy to move and adjust. Step 5. Connect causal relationships. Formally create a correlation diagram. Place the cards on the whiteboard or large paper. Use arrows to indicate the relationship of because. So, step 6, correct the graphics, insufficient discussion. Adjust the direction and position of the arrow. Remove the repeated or irrelevant factors. Supplement the omitted key points. Step 7, mark important items based on the number of arrow entries and exits. Distinguish between core and secondary factors. Mark the main cause and key intermediate factors with different colors or symbols. Step 8, form an article. Organize it into a written explanation or report. Accompany with text interpretation. Make it easy for others to understand. Step 9, propose improvement measures based on the analysis results. Develop specific and feasible improvement plans for the main causes and key intermediate factors. According to this process, you can quickly complete a standardized association diagram. After the production is completed, correctly identifying the factors is crucial. Remember the 4-sentence mnemonic. The arrow only goes in and does not go out is a problem. This factor is only influenced by other factors, but it does not affect any other factors. It is the core result we aim to solve. The main reason is that arrows only go out and not in. This factor only affects others and not be influenced by others. It is the fundamental reason. It is the starting point for improvement. The arrow represents both an input and an output, serving as an intermediate factor. It is both a cause and a result. It is the bridge for the spread of problems. The intermediate factor, where output exceeds input, is the key intermediate factor. It affects many other factors. However, it is influenced by a few factors. It is often the leverage point. Through the arrow flow direction, we can intuitively distinguish between problems, main causes, and intermediate factors. Quickly identify and focus on key areas for improvement. This is also the core usage skill of the association diagram. In practical operations, it is suggested that the team members make their own judgments first. Let's focus on the discussion again. Avoid groupthink. Besides, the counting of arrow numbers can be assisted by using markers or numbers. Improve accuracy to make it more intuitive for everyone to understand. Let's look at a practical case. The lighting system of a certain office building consumes a large amount of electricity. After analyzing with the correlation diagram, the improvement team found that the core issue is high power consumption for lighting. The main reasons include lax management, poor awareness of energy conservation, and unclear responsibilities. The intermediate factors include unauthorized wiring by property management, unauthorized use of electrical appliances, excessive lighting, multiple light fixtures, poor lighting conditions, centralized control of switches, inadequate inspection, ever-burning lights, and a lack of energy-saving education. All factors are interrelated. Ultimately, it points to the issue of power consumption. Based on this, the group formulated countermeasures in 3 aspects. In terms of management, it is necessary to clarify the responsible person. Establish a patrol system. In education, we should carry out energy-saving publicity. Post reminder signs on the equipment, replace the LED sensor light. Renovate the circuit. After implementation, the monthly electricity consumption has decreased by 35%. Although this case is set in an office setting, but it can be completely transferred to food factories. For example, the same method can be applied to large steam consumption in the workshop. Find out the main causes and intermediate factors such as valve leakage, operating habits, lack of insulation, and measurement errors. This can achieve cost reduction and efficiency improvement. Similarly, common issues faced by food enterprises include high rework rates, increasing complaint rates, and inadequate equipment cleaning. All are suitable for system analysis using association diagrams. Finally, let me emphasize the points to note when using the association diagram. First, it must be used for complex causal relationships. Simple problems do not require much effort. Second, the cause investigation should be comprehensively considered from 6 aspects: people, machine, material, method, environment, and measurement. Avoid omissions. Third, reasonably sort and swap the positions of the found reasons. Make the graphical logic smoother. Fourth, the key intermediate factors should also be treated as the primary cause. Prioritize improvement. Avoid ignoring the core links. Today, we systematically studied the comprehensive knowledge of the association graph. From definition, scope of application, characteristics, types, production steps, and identification methods, to practical cases and precautions. Progressive layers, it is a practical tool for sorting out complex issues and identifying the core root causes. Mastering it can make our food quality management work more efficient and precise. I hope that in future course designs, internships, or work, be brave to try using association diagrams. Turn it into a powerful tool for your own analysis and problem solving.